Hello ROS developers, welcome to a new live class where we are going to see how to represent into ROS the sensor data, but specifically for ROS2. Okay, so these are very basic concepts that are required if you are going to be a ROS developer. Then you need to learn how to represent the sensor information into ROS. Today we are going to see just a very simple example, including two informations that we are going to use and to visualize on the screen. And today is very special live class because tomorrow it's going to start the ROSCon, you know, the official ROS conference, worldwide conference, and we are here in Macau in China, and we are prepared, ready for tomorrow. But the problem is that due to different time zones and situations, so we cannot do a normal live class. That is why I decided to record it and then provide that to you from I'm here at the hotel room, and we don't have very good internet access. That means that it will be at 12 in the morning, I think. Well, I don't know how to say it in English, but it means that it's 12 in the night, I would say. Yeah, 12 in the night. And then the internet connection is not very good here at the hotel, so I decided to record it and provide you with the content anyway. So I'm going to share with you the ROSject that is going to be here below the video description, on the description note, so you can go there and find the ROSject there. You're going to see the link there. Okay, so I hope that this is useful for you and that you are going to learn. It's a problem that you cannot ask me questions, but I mean, you cannot ask me questions directly live, but you can put on the comments of the video. So if you have any questions, something is not clear, don't hesitate. Okay, so remember that we are going to do the usual procedure. So I'm here, I'm presenting to you, and now I'm going to share my screen and show you the ROSject link, and then you are going to get that ROSject link in the notes of the video, and then click on there. You will get a copy of the content that I'm going to show on the screen. Okay, so you are going to have the same things, and then you only need to follow the instructions that I will be giving to you during this video, and following on the screen also, of course. So you, by having this ROSject, you should be able to do the same things I'm doing on the screen. Okay, ready? Let's go. Okay, so let me first switch my screen here to, I have to switch to this one here. And now you can see here different ROSject I'm preparing. For the one of today is this one. So here I have a link, a button that says copy. So what I'm going to do is to copy this link. I'm copying the link, and then I'm putting now into the video description of YouTube here beneath, and that's it. So you got it. Then once you have it, you click on that link, and then you will get this, you will reach this page, but on your own user. Okay, so this is for myself, and then I have many different ROSjects of different subjects, and this is the one that we are going to do today. Okay, so if you click on that link, then you will get this ROSject on this page, on a page, a similar page for your case. Once you are there, click on open, and then again open. Okay, so if you click on there, then you are going to get into this page. I'm simplifying for here today, and it's a matter of time. Then you are going to reach this page where this notebook is automatically open, containing, this is a notebook, and then you can move it around, that contains the information, the code, and the instructions that we are going to follow today. Okay, so that's it. Then what else? Yes, so let me remind to the new users that in case that you get this closed for whatever the reason, you don't get this, no problem, don't hesitate. You can go to tools, then select Jupyter Notebook here option, select that one, and then you are going to get a list of the notebooks. In this case it's only one, so since there is only one, then it's open automatically this one. Well, so that's it. In case that you can create more notebooks, I will explain that in another video, but you can create your own notebooks the same way as I have created this. So I mean, this is completely editable, as you can see. Okay, so let's go with the lesson, because we need to finish on time. What is this about? It's about visualizing sensor data in ROS2. So probably you know already how to do it in ROS1. It's very simple. Then it's very similar in ROS2. The only thing is that we are going to play a little bit with the launch files, and that's it. So it's very simple stuff in this live class, but we need to provide this information. That's why we are here. So then it's very important to visualize the sensor data, because it's what allows you to debug errors in the robots. So you need to have a tool where you can see what is the current status of the robot, because the robot is, even if it is running your program, maybe your program doesn't crash, so it's a correct program, but the robot doesn't do what you want it to do. Then in that case, you need to debug your program, and for that you need to see what the robot is seeing, is perceiving, and that's the purpose of this live class. That's very, very important situation, and it's a tool that you are going to use a lot in order to debug these things. So let me remind you that the project has been created by Christian Chavez, who is an intern at the Construct, and by myself. And you can use it and freely distribute and copy and do whatever you want. What we are going to need here is to learn. So you must know basic knowledge. You must have basic knowledge of Linux, ROS1 basic. So you need to know how topics work, how to RBase works. Well, RBase maybe not necessary. You are going to see right here now, but the basic concepts of topics and subscribers and so on, and then a little basic knowledge of C++, and that's all, but very basic. Actually, not that much, but it's okay. And then we are going to learn how to visualize the sensor. Then this is a ROSJet, what you have copied, and then with that link is what we call a ROSJet. You have here more information about what a ROSJet is and how to create your own ROSJet. We are going to do a live class in 2 weeks from now. We are going to do a live class about how you can create your own ROSJets for your research, for your students, for a course that you are preparing, for whatever. So you can do the same things as I am doing here for you. Okay, and then what is the robot that we are going to use? It's the same that we have been doing and using along this month. That is this robot. It's called the Dolly. It's being created by Luis Pubel from Open Robotics, and we are using her code. Yeah, so that's it. It's a basic ROS2 enabled robot. And then let's start. So what we are going to do is we are going to repeat a little bit part of the previous live class. So we are going to create the package with the code that allows the robot to move around, and that's it, because well, just to repeat the same process so you can get some practice on this, and also because we are going to modify the launch file of that code in order to launch automatically the RBase. So we are going to see how to launch a simulation, how to launch a node that controls the robot inside the simulation, and how to launch the RBase program. All those things within a ROS2 launch file. So let's go. Let's start by creating the package that is going to contain the code that will allow the robot to follow a person. Okay, so let's go on that. So first we need to create a package in ROS2. Go to Tools, select Shell. Shell is a Linux terminal. Then we have it here. Maybe you will see that it goes a little bit slow, the opening and so on. That's due to the internet connection that we have here at the hotel. Now the first thing that we need to do is to source ROS2. In this case is the version of Dashing. So we are using Dashing for this class, but what we are showing here actually applies to any other version of ROS2. I mean, at least from the previous one, that was Crystal, the previous one. So because the concepts here are very basic, are very on the root of ROS2. So this can help to any other version of distribution. Sorry, distribution, that's the word. Okay, so we have to do the source in order to activate the package, the code of the commands and everything for ROS2. So you know the command is dashing setup.bash. Okay, and this is activating this shell, this terminal, to work with ROS2. So if you open more shells and you want to work with ROS2, you should do the same thing in other shells. You can come here and open it. Remember that here we are using the ROS Development Studio tool here for doing this thing, but the same things that I am doing here apply to your local computer. So if you are working on your local computer and you don't have the ROS2 source, the ROS2 environment sourced, then you will have this the problem that you cannot access the ROS2 commands and so on. So you need to do this. Another solution is to put this into the bash RC file of the system. So every time that you open a new terminal, this is automatically done. That's an option. We are not doing this here for several reasons. Anyway, let's go and create our ROS2 package where we are going to put the follow person code. Then we have here, so let's go to the ROS2 workspace. Remember that any package that you create for ROS, it has to be inside the workspace, a Catkin workspace there. And sorry, a ROS workspace, Catkin not anymore. It's a ROS workspace inside the source directory. And then now let's create our package by using this command that is here. You can copy paste directly. And let me copy and paste here. And let me explain you. Oh, I copied also the initial $sign, that this is not required. Okay, so the command is ROS2 pkg package create. Then the name of your package is going to be called my package, and then the build type, that is going to be ament-cmake. Ament-cmake is the type that we are going to compile our program for that. And then any package, any other ROS2 package that we require. In this case, because it's going to be a C++ code that we are going to put inside this package, then we need to include this dependency. This is for basic ROS2 code for C++. Okay, so that's it. The code, the package has been created. And here, yeah, here you have the explanation that I have explained to you. And now we can see this package. So if I do an ls, I can see here my package that's been created. But I can see also this on the IDE. Let's go here to the tools and open the IDE, where I'm going to see all my workspaces. And there are several workspaces already created for you. The one that we are interested here today is this one, ROS2 workspace, inside source, and here we have my package and the code. Okay, let's go and let's start. First, inside my package folder, let's create a launch directory. So you can do it directly from the IDE by doing here right click and then a new folder. And let's call it launch. Here is where we are going to put our launch file, and then inside that, then it says the instructions say that you should create a launch file. That in ROS2 launch files are actually Python files, and we should call it like this. So let me copy here the name so I can copy, and then here select on the IDE the launch directory, right click, and then new file. And now I paste the name of that I have here for in our notebook. So those notes, they are helping me to be consistent, so then afterwards the thing should work. Okay. Okay, so we have that file that is empty right now, but we are going to include the following code that you can see here. is this code here, and this is the actual code for a launch file. So what I suggest you is that you select this cell, then press Ctrl A to select the whole code. So now you have selected the whole code of the cell, you see, of the whole code. Then you press Ctrl C to copy, come here to the IDE, to the Python file, and then Ctrl B, or if you are in a Mac is Command B, Command C, etc. So once we have all this, let's have a look at the launch file, what it consists of. Basically, it has a couple of parts. First one is all those imports that you need to include. So please, whenever you create a launch file for ROS2, include all that by default. Then you have to create this function that is called generate launch description. This is mandatory, and this function has to return here a launch description, which is a list of all the elements here that you are going to launch, all the nodes that you would like to launch, and also some arguments. So declare some arguments that can be passed to those nodes in case that you need them. Then how do we define those elements that we are going to launch? That's the part that we have here. So you can see here that we're defining three parts, one for launching Gazebo, another one for the follow person program, and then the RBase program. The RBase, that is the visualizer that we want to use. And how do we do? Well, these are two different ways of launching. The first one is when you want to launch another launch file. So that's the case of the Gazebo one. So first you create a label, whatever it is. The label in this case is Gazebo, and you use this structure, that is include launch description, and then you include this Python launch description source, and indicate the path, the absolute path to the launch file that you want to launch. That is this one, gazebo launch.py. This is the one that is inside the launch directory, which is inside this package gazebo ROS. That is a variable that we have created here as is a variable that contains the absolute path to the gazebo ROS package. That's it. So here the only thing that we are doing is to concatenate this path with the launch directory and with the final launch file. So that is the structure that you have to use if you want to use to launch another launch file inside your launch file for ROS2. Then the second way of launching here is for launching a node. Then it's a very similar structure. You define a label for that node, and then you use the keyword node, and finally then you specify the package. Where is this node? In this case is my package. The node executable, which is not correct. Sorry, this is not correct because we have to change here. This is an error. So we are going to change this for the dolly follow. Here one, yeah, dolly follow. It has to be, the package has to be dolly follow. So this is dolly underscore follow. Why? Because the binary dolly follow is included inside this dolly follow package. That is the one that we have already installed here inside our ROS2 workspace. Let me clarify a little bit this. So this is my package, the one that we have created inside the ROS2 workspace, and then inside the dolly follow, well, this is not the package, this is just a directory. The name of the package is this one, okay, dolly follow, and that's the one that contains the binary. This is the CPP that will be compiled and generated the binary. Okay, so that's correct. So you specify the package name, the executable, then where it's going to be, the logs should be shown, and then in case that you need some remappings of topics. This means, the remappings means that the program, the dolly follow, is expecting to publish velocity commands on this topic, but the actual robot, the one that we are simulating, the name of the topic is called like this. So we are just connecting the actual name with the expected name by the program, and the same for the laser scan. And then for the RBase node is the same, but just simpler. It's just the package is RBase2 and the node The binary is ROS2, and we are including a condition that's a parameter that we can provide in case that we want to launch a configuration or not. And then, well, basically then we list all three here, and here we are declaring arguments for some of the nodes. In this case is for the launching gazebo node that provides an argument that is called wall, where we can provide a specific wall to be launched, and in this case we are providing is the dolly. Let me see here, we can see better the dolly empty wall, so it shows the dolly in an empty wall. And also we have another one for the ROS in case that we want to show the configuration or not. Then in this case is by default set to true. Okay, so that's basically the launch file. Then what else? What do we need? Okay, so now let's go and provide execution permissions to that file, to this launch file. For that, let's open a new shell, a new terminal, and let's go and do it. And now this is indicating that my connection is very bad to internet, so that's normal. Then if the connection is bad, then in the meantime let me move forward. That is connecting, so we are going to provide the permissions. Okay, so that is explained here. Connecting to the terminal, so it's taking some time. Then we have to modify the CMake list so that the launch file is installed into our system. So for that, let's go to our package that we have created, my package here, here, and then open the CMake list. And then you go to the bottom and indicate here, just before the amend package, you have to indicate this installation instruction. That is the one that indicates that the launch file has to be installed when we compile and source everything. Great, so we have it there. Then we got the terminal here. Let's go to the directory of the launch and provide the permissions with this command that you already know from Linux. So let's go to ROS2. Oh wait, before that, remember that we have to source the ROS2 environment. Oh no, this is happening when we have some problems with this connection of the internet, that the terminal is disconnecting. So let me go again. Before that, we remember that we have to source the ROS2 environment. So it's opt ROS, in this case is -in, and setup.bash. Done. And now let's go to ROS2, source, my package, launch, and then here let's provide with the command that you have on the notebook to the simulation launch file the execution permissions. Got it. Now the only thing that remains is that we build and install the package. So for that we use this command colcon build with the symlink install. But remember that we have to issue this command when we are in this directory. So let's go there. cd ROS2. Okay, so now it's time to compile. Let me copy the command, will be faster. Let's go. And yeah, of course it's very easy, very simple, also because we already have it compiled, the dolly follow program. It's already been compiled, and our new package doesn't contain anything, just install something. Now we have to source in order to have it everything everything that is taken into account, all the changes that we have done. So let's do install setup. So this is sourcing all the changes that we have done in our ROS2 workspace. That means the installation of the launch file. Great. Now we are on time. Then the next thing is that we are going to launch this. Remember that this is going to launch this simulation, the dolly follow program, and the RBase. So we should see all that. Then let's go. But before that, let me remind you to do this command. I am sorry that we have to do this command, because it's a command that is necessary only on the ROS Development Studio while we are solving a bug that we have. So it's copying a model of the female figure, so the gazebo window can reproduce the model. This is something that we are working on, and then in the next weeks you will not be necessary to issue this command. But for now, just copy and paste, and don't ask many questions about that, because you don't need to know about that. Okay, so done it. Then let's do the launch file. So ROS2 command launch. What's the name of the package? My package. And then what's the name of the launch file? Simulation launch file. Okay, there it is. There it goes. Don't worry about this red error. It's about it's a stupid thing, so it doesn't matter to the issue. Then everything has been launched, and we don't see anything here. Why? Well, because one is gazebo window. Then in order to see the gazebo window, you just go to Tools and select gazebo here. So now it says that simulation is running fast, because this problem with the network, I don't know how much it's going to take into account. So this is the simulation is running, and what it's remaining is to see here the image that is being loaded. Now another thing is the RBase. Where is the RBase? The RBase is a new window. It's another window, is a graphical tool that we are launching. So for that, in order to see that, we need to go to Tools and select Graphical Tools, and then here it should open. So it's connecting, but maybe we are going to have the same problem. That is going to take some time. Okay, it's waiting for the answer. Okay, loading. Here the simulation has appeared already, and we should see the person also here, because we have copied the model. I don't see it. Let's see if it appears in the meantime. I can see that this is going very slow. Oh, there it is. Great. So we have that. Then now we have here the window of the ROS2 that has been launched. So let me put on the middle by doing a double click here on the title. Then it's going to center everything. And we don't need this, so let me move on that side. Great. So we have the simulation with all the programs launched and the ROS2 system for visualization. We are great. So let's see what we have to do. So here is the result that we have. Here the other result. So let's start by visualizing the sensor data. And actually, no, we are going to start by visualizing the frames of reference. And as you probably know about TF. Okay? TF is the way that all the frames of reference in the robotics world that we are working with, in this case for the dolly robot, they are shown here on RBase. So we can see the relations between the different frames. So we are going to add a visualizer here that allow us to see all the frames that are defined in this world, all the ROS frames, all the TFs. Okay, so for that, let's go to Add, because we want to add a new visualizer, a new visualization stuff. Okay, so you add, and then you select the TF. Let's go on this list until you see the TF. Here it is. TF is for the frames, for the different frames. Here we can see a small frame, but this is not correct. Let me approach a little bit. So this is not correct. It should be here. So it should show something else. But what is the problem? The problem is that there is no transform from the fixed frame to map to whatever are the frames here. So what's the problem? That the fixed frame is expecting to have a frame called map. Then this is not correct, because our system doesn't have a map frame. Then we should change that. In order to change, click here on the name itself, and then click on this drop down menu, and then you will be shown with a list of available frames. In this case, only two: the chassis, that is the part of the robot, the base of the robot, and then the odometry demo, we call demo, but is the odometry frame. The odometry frame, remember, that is the frame that is started measuring the movement of the robot, and it starts the 0 at the position of the robot when it was switched on the first place. So let's select the odom demo, and then what we can see here are two frames, but we don't see the names. Let me see here on the configuration of the TF. There is an option here that you can add, that is show names. If you click on there, now that is better. So we can see the chassis, what is its relation with the odom demo. Okay, so let me show you one thing here on the screen, that because we have this follow person program running, we can move the person and then the robot will move in order to follow. So by doing this, we can see how the frames are going to change its relation in real time. So let's select the person, click on here, and let me do a refresh, because everything in white means that there is a slow connection. Let me refresh, and let's hope that this time it's going to be a little bit faster. Or maybe I messed it up everything, maybe, I don't know. I don't know. Let me see. And it is refreshing. I think that was a bad idea. So it's going to show in white again. And yeah, so what I'm going to do is to move the person. So by moving the person, the robot will move. And by moving the robot, this chassis frame should move to another location where the robot is in relation to the odometry frame. So you see that it's going to be this movement. So here it is. Now let me select the person and then select here to move and move it forward. Then once we are finished, click on here, so the robot has to approach, and there you can see that the frame is moving. And we can also, okay, so I have to move back. Yeah, there it is. Okay, great. So far so good. So you can see how to visualize the different frames. In this case, it's a very simple system. Only the chassis and the odometry frames, only two frames. Okay, this could be very, very complex for other robots. Now let's add something else. Let's add this sensor that the robot has. It has a laser that is detecting this person. So let's go to add, because we want to visualize the sensor laser. And here you have the laser scan. That's the one that you have to add. So click on there and then press OK. Now the laser scan appears in red because you have to configure the topic on which the laser scans should be obtained. Then click here on the arrow on the side, and here where it says topic, click there on the side, and also on the drop down menu. It will show you all the topics that appear on the system. Then the one that you have to select is the dolly laser scan, because it's the one that is publishing the laser. That's it. Now it's not red, and we should see here the laser. Let me see if I can move it and see the laser. Maybe it's very small here. Let me increase here the size. You can go here to the size, and let's put, instead of 0.0101. And okay, we should see it already. Am I measuring wrongly? Oh, let me see. I'm moving here in 3D. We should see the dots here. Ah, okay, yeah, I see. No, let me see, because it is not saying any problem, any error. So let me select here. We only have the chassis and the odom demo. Remember that the one that you select here is the frame on which the robot is going to the RBS is going to show the data. So now everything is centered on the chassis of the robot. That means the center of the robot. So this is the center of the wall, the chassis, because we have selected here, and then everything is going to represent around it. But if we select the other one, the other way around, then the center of the wall is the odometry demo. That makes more sense. Well, it depends on what you need to visualize. Okay, so but for now it's more intuitive if we have this as the center of the wall, and then all the things move around that there. Well, anyway, we should see here the laser data because it should be detecting this person. Let me add another object and see if there is a problem. Maybe this cylinder, and then let's see if the robot. Okay, so yeah, the robot is confusing the object by the person, of course, because it's closer, but it's not showing. And here we don't have any problem, so I presume that the laser is publishing in this frame of the chassis. I presume that. And also, let me see if I'm missing something here from my notes. So here's for the frames. I have already explained that to you. And then for the laser, yeah, so no, it should be correct. Yes, that's it. It doesn't have anything else. So let me launch another shell, another terminal, and let's see if it connects fast. This is strange because it should be showing here the laser scan. And let me see if I'm missing something. No, because that's correct. Flat squares, and okay, so is this option is, let me see why this option is to be included here. Okay, so it says that it's like there is no fast enough transform between here. You can see the error that appears, and here we can see it better. Yeah. Okay, so I see. It's because this transform between the chassis and the odometry for some reason is not produced properly. It's not produced, and then is let me see, it's like it's trying to get the transform into the future. So okay, so I don't know this problem what is, but it is only sometimes that is happening. So I should analyze what is the problem there. I don't know, but because sometimes this transform between the transform that defines the chassis and the odometry relation is not published properly sometimes, then that's why sometimes it gets it right and sometimes it doesn't. It has the error. Then that's why we had to establish this that option of unreliable in order to see the laser here, to be able to see the laser value. Now I should analyze what is the problem here because I didn't realize before this error. So, and that's not the problem of this class, of this live class. So let's reduce a little bit this size because it's too much. I think 0.5 is going to be okay. Yeah, so we can see here the data of the laser of the one person here, and then of the cylinder. If you select this and then you move it, you should see that remember that you move it here, but it's not actually executed this movement in the simulation until you press this. So that is why it doesn't change here. Okay, so now we change that here. You see that it's changed the position, but also now the robot is moving. You see that it's turning, and then everything, the perception is changing also. And basically those are the things that we wanted to show you for today. Those are only the things that very basics about the in ROS2, about the frames and about the laser sensors, the most basic things that you need to know in order to represent the status of the robot in the world. And yeah, that's it. On future ones, we are going to show more data and show you how to include more data, like cameras, like the model of the robot, etc., etc. But I hope that this is a short and nice introduction to what you need. Okay, so that's it, and that's all for today. And then live class, but I didn't break the line that we had, and also take the opportunity because we have already prepared this information for you and wanted to deliver, so next week we can move to other subjects. So stay tuned for the next live class that is going to be introduced along this week, and then I'll wait for you for the next live class. If you have questions about this one, just send me a message beneath this video. Thank you very much, ROS developers, and keep pushing your ROS learning.